Hello everyone and welcome back. In the last lesson we have introduced the concept of salting and why it's essential for creating password digests that would be resistant to dictionary attacks, or that would cause the attacker to have a lot more work to perform such type of offline attacks. The key takeaway there is that we should never simply take the password, apply a hash to it, and store the output directly on the database. That would still be very easy to get the password back using this type of attacks. We need a unique element, we need multiple iterations, and in general, we need a function that allows us to quickly calculate those safer password digests so that we can store them directly on the database. So what we need is what is known as a password-based key derivation function. So this is a function that takes as input the password, a salt, a number of iterations, and it's going to give us back the digest that we can safely store on the database, knowing that it would be very hard for an attacker to get back the password. It would be basically impossible. Now, Node.js comes in its crypto module with a function that allows precisely to do that. So it's a password key derivation function that takes as input the password, a unique salt, a series of iterations, and the output it's going to be the derived key that, if we choose a high number of iterations and a sufficiently random salt, would then be safe to store on the database. Let's then demonstrate how to use this function, and one of the things that we need is a random salt. So the crypto module comes here with another function which is called simply random bytes. What this function will give us back is a pseudo-random number that we can use as a salt. So we just need to make sure that the number of bytes is sufficiently high. So let's see how can we combine these two functions to produce a password digest that is safe to store in the database. Let's switch again back to WebStorm, and we are going to open here the hash.salt.js file. That is another small demonstration file of how we would produce such digests. So let's quickly review this program together. Let's actually run it first just to make sure that everything is working correctly. We are going to run here in the command line npm run hash and salt. So this is the output of the program. This is the result of hashing the password monkey. So let's see how this program works. We are going to use again the crypto module built into Node, and we are going to call the function random bytes. We are going to specify here how many bytes we need. This is going to give us back a pseudo-random number, which is going to be the salt, and then we are going to use it here as the input of our password derivation function. So one of the inputs is the password, the second input is the salt, which should be unique per user. So let's say that you were storing the user in a database table. Next to the user data, you would want to store the salt. There is an alternative way of storing it together with the digest. We're going to see that in a moment. Anyway, the salt should be stored together with the user data, and this is the number of iterations. So we are using the same iterations that were used in the code example in the Node documentation. This is the number of bytes that we would like to have in the output. This is the hashing algorithm that we are using here. For demonstration purposes only, we are going to be using a different hash in the implementation of our register service. And so this will give us back via this callback function the result of applying here this password derivation function. So we print it to the screen, and we have here something that would be much safer to store in a database. Actually, this is an exaggerated example because, as you have seen, it took a long time to compute, but this is the overall idea. Never to simply hash a password and store it on the database. Instead, do it multiple times and add an element to the input of our derivation function, which is unique to each user, with the purpose of preventing the attacker from pre-computing digests that could potentially be applicable to all the users. By using a salt, the attacker would be forced to compute these tables per user, increasing tremendously the amount of computational power and time that it would take to perform an offline dictionary attack. That's the whole goal of using salting and password key derivation functions. Given this introduction to hashing, salting, and dictionary attacks, let's now continue the implementation of our signup service. We're going to choose a hashing function and we're going to use it to store the passwords in our database. This is coming right up in the next few lessons.